Hello all. Today we are going to discuss about the different type of activation function that we used in neural network. So in this tutorial we are going to discuss about the sigmoid function, the hyperbolic tangent or the tanh, the rectified linear unit or the ReLU, and exponential linear unit or the ELU. So first we want to understand the activation function. In neural network, activation function plays an important role. Activation function determines the output of a deep learning network, its accuracy and computational efficiency of training the network. First, the sigmoid function. Here, this is the function that we used for the sigmoid. Z is the input to that function, f of z is the output of the sigmoid function. And as you can see, this f of z is nothing but 1 divided by 1 plus e to the power minus z. Here you can see the blue line. So this function will give the output between 0 to 1 and it is centered around 0.5. And this is the derivative of this f of z or the sigmoid function. Now we all know that when we are backpropagating in neural network or updating the weights, what we are trying to do, we are trying to find the derivative, and this is the way we are going to do the derivative for this sigmoid function. As you can see, it is very simple to find the derivative of a sigmoid function. Some of the properties of sigmoid function is as follows. It gives the output in range between 0 to 1. Historically popular because the sigmoid have nice interpretation as a saturating firing rate of neuron. Now some of the problems that sigmoid function have. First one is its output is not zero centered. As we can see, its exponent operations is compute expensive and saturated neurons kills the gradient. Now we will go to the hyperbolic tangent or tanh function. The tanh function look like this, right? Where fz is the input, as we know. So f of z is nothing but e to the power z minus e to the power minus z divided by e to the power z plus e to the power minus z. Here you can see the blue line. This can range between minus 1 to plus 1. And this is the derivative of the tanh function. Some of the properties of tanh function is as follows. It gives the output in range minus 1 to plus 1. It is a zero centered. The problem is that it kills the gradient when saturated. Now we will talk about the rectified linear unit, which is one of the most popular activation function used in. So all these method like sigmoid, tanh, ReLU, all are very much famous in the as a activation function. The function is very simple compared with the previous two, right? So here we can see f of z is nothing but the maximum between 0 and z. So this curve can give you that idea that when it is less than equal to 0, it is always 0, and when it is greater than 0, it is always the input. So the derivative is something like this. When it is greater than 0, then it is 1, and it is 0 if z is less than equal to 0 or the input is less than equal to 0. Some of the properties that ReLU have, in positive region it doesn't saturate, as we can see. Converges much faster than the sigmoid and tanh. Computationally efficient, as we can see in the first sigmoid and in tanh, that we need to do some level of calculation like e to the power z, right? But here there is nothing, so it is very computationally efficient. But some of the problems are it is not zero centered and dead ReLU never active, so then it will never update, which is very important, right? Now we will discuss about the exponential linear unit or the ELU. It looks like this. F of z is equal to z when z is greater than 0 and alpha into e to the power z minus 1 when z is less than equal to 0, and this is the curve of this ELU function. As we can see, if we go positive side, it is just something like ReLU, right? but in the negative side also it is giving the output. So this is the derivative of the ELU function, and some of the properties is that it gets all the benefit like ReLU. As I already said, it doesn't die, as we can see, and closer to zero semi output, which is also good. But it has a problem. The problem is exponent operation is quite compute expensive. As we can see here, we are doing the exponent operation, which is quite expensive, right? So in this tutorial we understood about sigmoid, tanh, ReLU, ELU, and also saw their functions and the curve. If there any question that you have, please comment below. Thank you.